Good afternoon, everyone. I hope you all enjoyed the earlier sessions today. The topic for this session is ANOVA using SPSS software, which will be delivered by Jonali Gogoi ma'am. Ma'am, we humbly request you to begin your sessions. Thank you.
Hello everyone, I welcome all of you to my fourth presentation of this one-week faculty development program on scientific software. Today's my presentation topic is analysis of variance using SPSS. Now first I am going to discuss some theoretical concepts of analysis of variance and also some important terms which are related with analysis of variance. This is my objective slides. Here I am going to discuss about the definition of analysis of variance, assumptions of ANOVA, use of ANOVA, then as statistic, then what is null hypothesis and alternative hypothesis, then also level of significance, then degrees of freedom, linear model, and what are the models of analysis of variance, one-way analysis of variance and two-way analysis of variance, and at last I am going to discuss how to perform analysis of variance in SPSS. So now, what is ANOVA? ANOVA or analysis of variance. ANOVA stands for analysis of variance and tests for differences in the effects of independent variables on a dependent variable. I have already discussed in my earlier presentations about dependent and independent variables. Suppose we consider a straight line equation y equal to a plus bx, and in that equation we can say that y is dependent variable and x is your independent variable. Or we can say ANOVA is a statistical formula which is used to compare variances across the means or average of different groups. And this is also a versatile and powerful statistical technique and the essential tool when searching for multiple groups or categories. So as a definition, we can say the total variation present in a set of observable quantities may under certain circumstances be partitioned into a number of components associated with the nature of classification of the data. So the systematic procedure of classifying this variance is called analysis of variance, or in short ANOVA. So this is the definition of ANOVA. Then now I am going to give one example. Suppose we have considered some random samples of mangoes which are selected from 3 fruit trees, and a certain weight is conducted for those mangoes and their weights are noted. Okay. So the total variations are measured by the sum of square of deviation of weights from the mean weight, and in this case there are two sources of variation present into which the total variation may be partitioned. Okay. So first, the weight of mangoes from a particular tree varies within itself, and that is true for all the trees. And second, there may be an effect of trees on the mangoes, and hence the mean weight of the mangoes in the different trees varies from each other. So this example shows that the total variation is partitioned into two components, within the trees and between the trees. So this is the example of analysis of variance. Now, what are the assumptions of analysis of variance? For the validity of F test in ANOVA, these are the assumptions which are made for analysis of variance. So the observations are independent. This is the first assumptions of ANOVA, and the parent population from which the observations are taken is normal in nature. Third assumption, the various treatment and environmental effects are additive in nature. The population variances of each of the groups should be equal. So these are the assumptions of analysis of variance. Next, use of ANOVA. ANOVA is used to test the hypothesis about differences between two or more means. or ANOVA test is a statistical significance test that is used to check whether the null hypothesis can be rejected or not during hypothesis testing. So what is null hypothesis, I am going to explain in later. An ANOVA test which can be either one way or two way depending upon the number of independent variables. So this is the use of ANOVA. And then what is F statistic? So this is a very important statistic in case of analysis of variance. How we can explain this F statistic? The ratio of two chi-square variate with respect to their degrees of freedom is F variate. Again I am going to explain what is degrees of freedom. That is, if chi n1 square is a chi-square variate with n1 degrees of freedom and chi n2 square is a chi-square variate with n2 degrees of freedom, then we can define F variate as F equal to chi-square n1 divided by n1 then whole thing divided by chi-square n2 divided by n2, which follows F distribution with n1 and n2 degrees of freedom. So this is the F statistic. Next, what is null hypothesis? A null hypothesis is a hypothesis which is taken up for testing whether it can be rejected or not. Usually, it is a hypothesis which assumes that the sample characteristics is not different from the population characteristics. And generally, null hypothesis is denoted by H0, and it represents an assumption that no significant difference, effect or relationship exists between variables within a population. This is about null hypothesis. And next, alternative hypothesis. So the hypothesis against which the test is proceed is called an alternative hypothesis. An alternative hypothesis is a hypothesis which is complementary to the null hypothesis, and generally an alternative hypothesis is denoted by H1 or we can say HA, A for alternative. So the alternative hypothesis is one of two hypotheses in a hypothesis test. It states that there is statistical significance between two variables. This is all about alternative hypothesis. And the next, level of significance. So what is the level of significance? This defines level of significance defines whether the null hypothesis is assumed to be accepted or rejected. It is the measurement of the statistical significance, and it is denoted by Greek letter alpha. It also defines whether the null hypothesis is assumed to be accepted or rejected. I have already told you. So, generally we use 5% or 1% level of significance. A level of significance of p equal to 0.05, which means what? This means that there is a 95% probability that the results are found in the study are of a true relationship between groups being compared. Or we can say there is a 5% chance that the results were found by sons alone, and there is no true relationship exists between groups. This is all about level of significance. Next, what is degrees of freedom? The degrees of freedom in a statistical calculation represent how many values involved in a calculation have the freedom to vary. It can be calculated to help ensure the statistical validity of chi-square test, t-test, and even more advanced f-test. And the number of degrees of freedom refers to the number of independent observations in a sample minus the number of population parameters that must be estimated. Next, linear model. So, what is linear model? Suppose we are considering, here you see y1, y2 up to ... yn be n observable quantities, and in all classes we shall assume the observed value to be composed of two parts. that is yi equal to mu I plus epsilon I. So here mu I is called your actual value and epsilon I, this is called the error of measurement. We can write this is ei also, small ei also to denote the error of measurement. And the true value mu I is assigned again assumed to be a linear function of k unknown quantities. So which are tau 1, tau 2 up to ... tau k, which are called as fx. And this linear function may be expressed as mu I equal to ai1 tau 1 plus ai2 tau 2 plus ... plus aik tau k. So these are up to k unknown quantities when ai's are known, and this setup is called as a linear model. Now we move to this slides. Models of analysis of variance. There are three models in analysis of variance. First one is fixed effect model, which is called model 1, or this is also called linear hypothesis model. Second one is called random effect model or model 2, or this is also called variance component model. And third one is mixed effect model, or this is also called model 3. So how we can explain about three models? A model in which each of the factors has fixed effects and only the error effect is random is called a fixed effect model. Models in which all the factors have random effects are called random effect model. Models in which some factors have fixed effects and some factors have random effects is called as a mixed effect model. Now again you see from this linear model, here we made two assumptions. This tau I goes from 1 to k. So these tau i's are always independent random variables, and epsilon i's have expectation 0. So this type of model is called your fixed effect model. And a model in which all the tau i's are random variable except the additive constant, then the model is called as a random effect model. And a model in which at least one tau i's is a random variable and at least one tau j is a constant is called as a mixed effect model. Okay, I think I hope this is clear for you. Now one-way analysis of variance. So what is one-way analysis of variance? The first point, the one-way ANOVA is an extension of the t-test used for comparing difference between two sample means. Here we can compare the significant difference for population means of more than two groups, and the total variation here is divided both among and within the groups. The within group variation is called your error variation. And in one-way ANOVA, the total variation is partitioned into two parts. One amongst the groups, which is also called as among treatments, and the other within the groups, which is called error variation. And here you see I have given total variation equal to variation among groups plus variation within the group. Next, this is one-way ANOVA observation table. So here you see A1, A2, AI, up to AK, and this side Y11 for A1, Y11, Y12, up to Y1Z, up to Y1N1. And mean for this is Y1 not or dot bar. This is also called not or dot. So Y1 not or dot bar. And for A2, Y21, Y22 up to Y2Z up to Y2N2. And the mean for this is Y2 dot bar. And similarly AI for AI, yi1 yi2 up to yiz up to yini. This is the mean for ai, yi not or dot bar. And similarly for ak, yk1 yk2 up to yknk, and this is the mean for yk dot or not bar. And this is the observation table. So how we can explain? Here we have considered a factor A which has k classes, A1 to up to k, ak. So a factor, we are considering here the factor A which has k classes, that means A1 to up to ak, and the number of observation in the ith class, here I equal to 1 to k is ni, small ni, and we can say summation over I goes from 1 to k small ni, this is equal to small n, and let Yij denote the zth observation in the ith class. This Yij, these are the jth observation in the ith class. So here I goes from 1 to up to k and j goes from 1 to up to small ni. So this is about observation table of one-way classification. Now you see what is the model for one-way classification. So here Yij equal to mu plus alpha I plus Eij, or we can say epsilon ij. So this is the fixed effect linear model for one-way classification. Here mu equal to general mean effect. Mu is called general mean effect. Alpha is called effect due to the ith level of factor A. Epsilon ij is called the error effect. And here also we made two or three assumptions. All the observation Yij are independent. This is the first assumption. The second assumption, we can say summation over I goes from 1 to k ni alpha I, this is equal to 0. And third assumption, epsilon ij's are distributed as a normal variate with mean 0 and variance sigma is square. Okay, this is the linear model for one-way analysis of variance. Now after doing our statistical analysis, we'll get our ANOVA table. Now here you see in first column source of variation, in second column degrees of freedom, third column sum of squares, fourth column mean sum of square, and for fifth column f tabulated, that means the calculated value of f, and f tabulated, this is in sixth column, this means the tabulated value of f. Here we have considered treatment, that means factor A. So an error, then total. So what is the degrees of freedom for treatment or factor A? This is k minus 1. And for error, this is n minus k. And for total, n minus 1. What is the sum of square for factor A? S square A. Or we can say this is SSA. And for error, S square E. E for error. Or we can say SSE. Or for total, capital S square. Or we can say TSS. And then mean sum of square, MSA, we denote this for factor A, MSA, this is equal to small a square. And MSE, this is equal to small e square, small e square. And for F calculated, FA, this is the F statistic for factor A, this is equal to S square A by S square E. And this is F tabulated value, this is at 5% level of significance with respective degrees of freedom. K minus 1 and n minus k. So here you see this table is used to test the hypothesis that population means of the different groups does not differ significantly. That is, S naught colon mu1 equal to mu2 equal to dot 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 equal to mu k. And this is tested against the alternative hypothesis that H1, at least one of them is significantly different. So from here, how we can conclude our ANOVA table, how we can give the conclusion part for this table. If the calculated value of FA, this FA is less than the tabulated value of F for K minus 1 and n minus k degrees of freedom at a certain level of significance, generally we consider 5% level of significance, then we accept our null hypothesis at the level of significance. And we may conclude that there is no significant difference between different levels of factor A, or otherwise we reject our null hypothesis. This is all about one-way analysis of variance. Now, two-way analysis of variance. How we can define two-way analysis of variance? In statistics, the two-way analysis of variance is an extension of the one-way analysis of variance that examines the influence of two different categorical independent variables on one continuous dependent variable. The two-way ANOVA or analysis of variance allows one to consider simultaneously two known sources of variation among population means. And in two-way analysis of variance, we can test two null hypotheses simultaneously. Okay. Then, when we use our two-way analysis of variance, a two-way analysis of variance is used to estimate how the mean of a quantitative variable changes according to the levels of two categorical variables. We can use two-way ANOVA when we want to know how two independent variables in combination affect a dependent variable. Okay. So, this is the observation table for two-way analysis of variance. Here factor N, factor B. So, A1, A2 up to AP and B1, B2 up to BQ. Then these are the means and this is called the grand total. So, how we can define this observation table, how we can explain? Suppose we have two factors, capital A and capital B, where A has P levels, that means A1, A2 up to AP, and B has Q levels, that means B1, B2 up to BQ. And let Yij, here I equal to 1, 2 up to P and J equal to 1, 2 up to Q, which denote the observation for the ith level of factor A and jth level of factor B. Then after that we can prepare this observation table. And these are the means for factor this A1 Y1 not bar, for A2 Y2 not bar, and AI this is YI not bar, AP YP not bar. And this side also for B1 Y not 1 bar or Y dot 1 bar, Y dot 2 bar, dot Y dot J bar, dot Y dot Q bar. So this is the grand mean Y dot bar. This is the observation table for two-way analysis of variance. Now, what is the linear model for two-way analysis of variance? This one is Yij equal to mu plus alpha I plus beta j plus epsilon ij. In one-way analysis of variance, Yij equal to mu plus alpha I plus epsilon ij only. But in case of two-way analysis of variance, you add one beta j here. And here, mu is called general mean effect, alpha is called effect due to the ith level of factor A, beta j is called effect due to the jth level of factor B, and epsilon ij, this is called the error effect. And from this model, we can make two assumptions. Epsilon ij's are independent and identically normally distributed with zero mean and variance sigma I square. And summation over I, alpha I equal to summation over j, beta j equal to 0. These are the two assumptions on the basis of this model. Next, this is the two-way analysis of variance table. So, after doing our statistical analysis, we can prepare this two-way ANOVA table. Here, first column is your sources of variation, second column is your degrees of freedom, third column is your sums of square, and fourth column is your mean sums of square. And fifth column is your F calculated, that means calculated value of F. And sixth column is your F tabulated, that means F, tabulated value of F. And here in sources of variation, you see factor A, this is a treatment, we denote here, then factor V, this is varieties, and error, then total. So the degrees of freedom for factor A is P minus 1, the degrees of freedom for factor B is Q minus 1, and P minus 1 into Q minus 1 is the degrees of freedom for error, and PQ minus 1 is the total degrees of freedom. This is SS, sums of square. This is SSA, sums of square for the factor A, this is equal to SA square. SSB, sums of square for the factor B is equal to SB square. SSE, sums of square for the factor A, this is equal to SE square. And TSS means total sums of square, which is equal to capital S square. And mean sums of square for factor A, which is denoted by MSA, this is equal to SSA by the respective degrees of freedom P minus 1. And this is also we can write small s square A. and mean sums of square for factor b, which is MSB equal to SSB by Q minus 1. And MSE, mean sums of square for error, this is equal to SSE by P minus 1 into Q minus 1. And FA, that means the F value for the factor A, this is equal to SA square by SE square. FB, for the factor B, this is equal to SB square by SE square. And F tabulated, these values we are getting from the table. At 5% level of significance we are considering with the respective degrees of freedom. Then the above table is used to test the hypothesis that population means due to the different treatments does not differ significantly. That is, S01 colon alpha 1 equal to alpha 2 equal to dot 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 equal to alpha p. And also for tested the null hypothesis that the population means due to the different varieties does not differ significantly. That is, S02 colon beta 1 equal to beta 2 equal to dot 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 equal to beta q. So how we can draw conclusion for this table, for this two-way ANOVA table? If the calculated value of FA, that means the for factor A, is less than the table value of F for P minus 1 comma P minus 1 into Q minus 1 degrees of freedom at a certain level of significance. Generally we are considering 5%, I told you. And then we may accept the null hypothesis and conclude that there is no significant difference between the different levels of factor A, or we can say for treatment. Otherwise we reject the null hypothesis. And similarly we can draw the same conclusion for the factor B or varieties. Now we come to the last point of our presentation. That is how to perform ANOVA, analysis of variance in SPSS. Now I am going to show you. Here you see, I have considered this objective to investigate the effects of chemotherapy, tumor stage and their interaction on overall survival in months among cancer patients. And this is the dataset overview. Total patients here I am considering 1455. This dataset on the basis of cancer patients. And here note that for one-way analysis of variance, we will consider only chemotherapy as independent variable, and for two-way analysis of variance, we will consider both chemotherapy and tumor stage as independent variables. Here, overall survival months, continuous variable representing survival time, and chemotherapy categorical variable, and tumor stage categorical variable. Here we are considering stage 1, stage 2, stage 3 and stage 4. Now you see, this is one-way ANOVA. I will show you the dataset later. First you see how to perform this one-way ANOVA in SPSS. Just I have given this screenshot for you. This will help you in future to do or to perform one-way analysis of variance. First you go to analyze, then click on compare means, then click on one-way ANOVA. Here you see these are the three steps here. First analyze, compare means and one-way ANOVA. Then after that you see bring the target variable in the dependent list. So it will come this window after performing three steps, dependent list, overall survival months. So this is the target variable, and for factor to bring the factor in the factor box, just you click on chemotherapy, then it will come here and then click OK. Then you will get the result. So this is the result of analysis of variance and how we can interpret. So the ANOVA results demonstrate that there is a significant difference in overall survival months among the different treatment groups. P less than 0.001. You see significant value is this 0.001. This suggests that at least one treatment group has a significantly different mean survival time compared to the others. Here you see the values of sums of square, degrees of freedom, mean square and F, then significant value. So this is between groups and within groups, and this is the total, and this is the total degrees of freedom. This is for one-way analysis of variance. And now you see for two-way analysis of variance, what we have to do? First you click on analyze, then go to general linear model, then go to your univariate. Okay, these three steps here again. Then you see bring the target variable in the dependent list. So what is our target variable? Overall survival months. And then bring the factors in the fixed factor box. So this is chemotherapy and tumor stage, and then you click on OK. After doing this, you will get this ANOVA table. Here you see dependent variable, overall survival mass, source, these are the sources, and type 3 sum of squares, and degrees of freedom, then mean square, this is the F value, and these are the significant values, P values. Okay. So from here you see the 2A ANOVA results indicate that both chemotherapy and tumor stage significantly affect overall survival mass. And there is a significant interaction between chemotherapy and tumor stage, suggesting that the effectiveness of chemotherapy varies depending on the tumor stage. And the model explains a small but significant portion of the variance in survival times. And here this is the R-squared value 0.095. Now I am going to perform this one-way analysis of variance in SPSS. So for this, we move to our SPSS window. You see, I have already opened my data set. This is the cancer patient data set here. So now I am going to perform first one-way analysis of variance. Here you click, this is the data set, this is data view window, and this is variable view window. If you have any doubt, I have already entered all those data sets for time saving. If you have any doubt, you can ask me later, but if you see this variable view window and data view window, you can enter your data by yourself. Okay, so now move to our analysis purpose. Go to analyze, then compare means, and then one-way ANOVA, you see. Okay, then click on one-way ANOVA. What will come? This is chemotherapy, then overall survival months, tumor stage, and just you click overall survival months in dependent list. Okay, so you click on here and then click here, it will come in dependent list. Okay, and then you take chemotherapy. This is, we are doing here one-way analysis of variance, that's why you click on chemotherapy, then you bring it to our factor box. Okay, chemotherapy is here in factor box, then you click on OK. So this is the result. Okay, analysis of one-way analysis of variance result. You see from here also, this is the result. So I have already demonstrated about these results. Then again we move to our two-way analysis of variance. Okay, so for this two-way analysis of variance, here you see how to perform. This is analyze, general linear model, then univariate. So go to the this window, and then you click on analyze, then general linear model is here, then univariate, click on here, then it will come, and we are going for two-way analysis of variance. So you just click on overall survival months in dependent variable list, just click here, it will come dependent variable list, and then you select this chemotherapy and then click on here, it will come fixed factor box, and then you again click on tumor stage and then click on here, then it will come in your fixed factor box, and then you click on OK. This is for two-way analysis of variance, that's why we are considering here chemotherapy and tumor stage at fixed factor box. Okay, so this is the result, and you see here, from here you see the result I have already explained. Okay, this is all about two-way analysis of variance. So this is very easy how to perform in SPSS one-way and two-way analysis of variance. So this is all about my today's presentation. I hope all of you have learned something about SPSS from my presentations, all the presentations, and I thank you all the participants for listening to me. And I also thank you Dr. Dimpalajyoti Mohanto sir for inviting me as a resource person for this one-week faculty development program on scientific software and giving me the chance to share my knowledge with you. So thank you once again. Have a nice time ahead, and I conclude here. Thank you.
Thank you, ma'am, for the informative session. I hope it will benefit our participants. I also want to thank Professor Bipon Hazarika sir for clearing the participants' doubt on latex. I believe everyone enjoyed the sessions delivered by the experts. Once again, thank you all for attending. We look forward to seeing you again tomorrow with some new and interesting topics. Thank you.